All right, compound events. Combines two or more events using the word and or the word or. We've already kind of talked about the or. What did we do on those? You add. If it says this or that, we're going to add something up. If it says and, we're going to multiply something. And we'll get to it in what we're actually doing. Mutually exclusive. Two or more events that cannot occur at the same time. They have no common outcomes. All right, and when we start looking at the problems, you'll see what it means when it says cannot happen at the same time. Overlapping, on the other hand, they can happen at the same time, and we've got to do that one a little bit different. All right, mutually exclusive, again, means it cannot happen at the same time. What you're going to do on mutually exclusive, if it says A or B like it does here, you're going to find the probability of A, find the probability of B, and add the two things together. The Venn diagram down here is just showing what it would look like. For example, if I said I'm going to flip a coin and then pick a marble out of a bag, does me flipping the coin have anything to do with me picking the marble out of the bag? No. None whether, I mean, I can flip heads 100 times in a row and that's not going to change what I pick out of the bag. That would be mutually exclusive. So the first thing has absolutely nothing to do with the second thing. All you have to do on those is just add up the probabilities. All right, mutually exclusive, again, cannot happen at the same time. In this case, I can't say math is my favorite subject and science is my favorite subject at the same time. I got to pick one or the other. All right, the rule says all we got to do is add up the two choices. So what is the probability of picking math out of that group right there?
0.25.
0.25. So there's my A and there's my B. So I say, well, there's 0.25. Or means add. Science is 0.20. Add those up. 0.45. Now, most of the time when we do probability, we're going to do fractions, but it can be decimals. But the same rules are going to work. It's got to be between 0 and 1. All right. Find the probability that a girl's favorite subject is not English. Well, if it's not English, that means it is math or social studies or science or history. So in this case, I'm not adding A or B. I'm adding A or B or C or D, just adding them all up. So not English would be the math plus the social studies plus the science plus the history. If I wanted to change those to percentages, what would the percentages be for 0.45 and 0.90?
45%.
And
90%.
45% and 90%. All right, I go down to back to the deck of cards we talked about last week. Find the probability of picking an ace. There's my A. Or a queen. There's the B. How many aces are in the deck?
4.
Out of
52.
And then queen would be
4 out of 52.
That's a total of 8 out of 52, which winds up being 2 out of 13. It's the same. We've already done that type. You just take the first probability, the second probability, and add them up. After rolling 2 dice, what is the probability of getting a sum of 7 or 8?
11.
In case we don't remember, there's going to be 6 7s in there, and then 5 8s. So I'll do 6 over 36 for the 7, 5 over 36 for the 8, and get a total of 11 over 36.
So you didn't remember.
All right, overlapping events, on the other hand, can happen at the same time. To do that probability for this one, if they can happen at the same time, you have to find the probability of the first one, add the probability of the second one, but then subtract off the probability of both of them happening at the same time. And hopefully it'll make a little more sense when we're doing the problems. But it's a different form now when it's overlapping. If they can happen at the same time, we've got to do a different formula there for the probability. All right, if I want to look at these, it says I have 4 red cards, 1 through 4. And then blue cards, 1 through 5. All Alright, so that's what I'm looking at to start with. If I look at this first one, it says find the probability of picking a red card or a 3. The question is, can I have a red card that is a 3?
Yeah.
If you can, that's overlapping because it's doing both of these things at the same time. It's being red and it's a 3. So if it overlaps, I've got to go back and do that. Find the probability of the first one, probability of the second one, and subtract the probability of both of them happening at the same time. So when I come here, what's the probability of getting a red card?
4.
Out of
9.
So 4 out of 9 for the red. Plus, what's the probability of getting a 3?
2 out of 9.
2 out of 9. Minus, what is the probability of having a red 3?
1 out of 9.
Type that on the calculator, you got your answer. You should be able to do it without the calculator, but. Alright. 4 plus 2 is 6, 6 minus 1 is 5.
5, 9.
Alright, see if you can do that second one right there. Alright, what would probability of picking a card less than 3?
4 out of 9.
Yeah, there's 2 on the red and 2 on the blue, so that's 4 out of 9. Or a blue card, which would be 5 out of 9.
And then 2.
Minus,
2 out of 9.
it needs to be a card less than 3 and blue. There's 2 of those. Everybody good with that? Card less than 3, there's 4. Blue card, there's 5. So then I go, can it be less than 3 and blue at the same time? Yes, there's 2 of those. That winds up being what? 7. Alright, back to the dice stuff. Hopefully you still got the chart. Tell you what, let's do this real quick. Alright, so got my chart. Probability of getting a 6 or a number less than 10. Well, both of those can happen at the same time, so that makes it overlapping. What is the probability of getting a 6? How many 6s are in that chart?
7.
What?
6.
5, ain't it?
Oh, I was counting
The outside now, that's not
Yeah.
the chart. The blue part is not the chart. So there's 5 out of 36 that are 6s. Or a number less than 10. So I count up the ones that are less than 10. Well, what I'm going to do is say, look, there's 6 of them that are 10 or bigger. So 36 minus 6 would be 30 of them are less than 10. Then I've got to subtract off the ones that are 6s, because those are less than 10. Does that make sense? There's 6s and less than 10. 6 or a number less than
30 minus
10. Make sure I'm doing this right. Alright, so I got my 6, probably will get a 6, a number less than 10. Now I'm picking one thing. So when I pick my one thing, what is the probability of it being a 6 and less than 10 at the same time? If I'm picking one thing, it can only be one choice. Does that make sense? If I pick one number,
That's just
the probability of it being a 6 is the 5. The probability of it being less than 10 is 30. Well, if I'm only picking one number, the chances of it being a 6 and less than 10, it's only that one.
So it's kind of like what you did with 3 up there too? How
Yeah.
it was-
Yeah. Alright, so that would wind up being 35, 34 over 36, which is 17 over 18. Then I go to the last one down there, probability of getting an odd number. So how many are going to be odd up there? Half of them. So that's going to be my 18 out of 36. Plus a number greater than 8. How many numbers are up there greater than 8?
10.
Alright.
Sorry.
Minus the odd numbers that are also greater than 8. How many odd numbers are greater than 8 up there? I got my 4 9s right here and then 2 11s, so that would be 6. So that's 28 minus 6 is 22 over 36. Get 11 over 18. So So if I want to determine mutually exclusive or overlapping, mutually exclusive cannot happen at the same time, overlapping can. So the first one, can I pick a king and a queen at the same time? No. So that would make it mutually exclusive. You cannot do both things at the same time. A 7 or a club. Can it be a 7 and a club at the same time? Yes. So then that one's going to be overlapping. A face card or less than 5.
Exclusive.
Mutually exclusive because I can't have something less than, less than 5 and be a face card. A red or a 10. That can happen at the same time. Alright? Then it says using students in a high school, picking a freshman or a girl. That can overlap because you can be a freshman and a girl at the same time. A junior or a senior. You can't do that at the same time. A girl or a boy, mutually exclusive. And picking a football player or a senior, that can happen at the same time. So we've got to be able to do that in order to answer the question because that tells us which way to do it.
backwards.
I was wrong. It was 20.
Alright, first thing, mutually exclusive or overlapping for king or a club. It's overlapping because it can be a king and a club at the same time. So if it's overlapping, I've got to do this. Probability of the first plus probability of the second minus probability of both. So what's the probability of getting a king?
4 to 52.
Plus the probability of getting a club.
13.
13. Minus the probability of getting a king and a club.
17 of
There's only one that's a king and a club at the same
So you
time.
have a king club. No, because it's on the
What's the probability of getting a king? There's 4 of them. What's the probability of getting a club? There's 13 of them. What's the probability of getting a king and a club at the same
king
time?
of a club?
There's only one king of clubs.
There's going to be 16.
Wait, you're talking about the club, right?
No.
On the second one, it was clubs.
Yeah, there's 13 clubs.
There was 4.
It's only one
1, 2,
king
3,
of club.
4, 5, 6, 7,
Like
8,
you got
9,
a
10,
king,
11, 12, 13.
you got a king of clubs, king of king
Oh,
of
10.
count
There's 10, 11, 12, 13. There's 13 clubs.
Okay, I thought that was
Alright, so that winds up being 16 over 52. You wind up with 4 over 13. Alright, the second one. Probability of a number less than 5 or a diamond. Mutually exclusive, overlapping.
overlapping.
Overlapping because it can be less than 5 and a diamond. How many numbers are less than 5?
12. Whatever 4 times 4 is.
16.
16. There's 16 cards that are less than 5. Or a diamond. Well, how many diamonds are there?
13.
Y'all.
13.
13. There's 13 clubs, 13 diamonds, 13 spades, 13 hearts. Alright, minus how many are less than 5 and a diamond?
4.
4.
So wouldn't that translate?
5 over
I
13.
can't be simplified.
King or club, can they happen at the same time?
Yes.
Yes. So that means it's mutually overlapping, which means I do the first thing. So the probability of a king is
4 out of 50.
plus the probability of a club, which is
4 out of 52. 1 out of 13. 13 of 52.
thank you, 13 out of 52. 13 clubs up there.
How?
My,
Hey,
13 clubs.
hey. I was thinking the club was a face card. Yeah.
All right, so 4 out of 52 are king, 13 out of 52 are clubs, minus how many are kings and clubs at the same time? Only one. So this is what I'm talking about with the simplifying. You start simplifying it early, you wind up with different denominators, which it just makes it easier to do it this way. 16 over 52, which is 4 over 13. All right. Probability of a number less than 5 or a diamond. Can it happen at the same time?
Yes.
So it's overlapping, which means I've got to do the same process. How many are less than 5? There's 16 that are less than 5. All right. Or a diamond. Well, there's 13 diamonds.
King is gonna be 12.
So how many are less than 5 and a diamond at the same time would be 4.
4.
And 12.
So that's 29 minus 4 is 25.
So it'd be 330.
That's crazy.
All right. Can it be a heart and an even number at the same time?
Yes.
So heart would be 13 out of 52. Even number, again, for our purposes, we're going to count this as my number group, and then the others are going to be face cards. So there's 20 that are even in that group. So heart and even. So that winds up being
28 over
28 over
52 is
52.
going to be 7 over 13.
all right, black card or a face card. It can be a black face card. So black card would be 26 out of 52. Face card is 12. Minus black and a face card at the same time.
32 over 52 is going to be 8 over
8
13.
over 13.
Red or odd. Well, red is 26. Odd is 20. Minus red and odd. Do what, 10?
36 over
36,
52
and
is
then
9 over 13.
So wait, my question is, what happens if it's multiply exclusive?
Then you